Okay, for the break, did a quick pass of methods. Again, the reading assignment for this week is should have called it a skimming assignment. You all had introductory logic. You don't need you don't need to hang on every word in the chapter because a lot of that is intended for people being introduced to logic. So skim through there, you'll see some stuff. Our example was starting to run long, so I did run out of time to do one thing. We set that method up to take in an array of these main classes that we're making. So we can pass in several of them. So maybe a new main that has the message of here's something else. And another new main. That just leave that one message blank. You see what I did there? That's very different than what was done earlier. So one earlier was just in a single one line. It's like a lot of caution taken about it, right? We declared what type of data we had, gave it a name so we can refer to it, and then we did the actual instruction to create it. But on these, I just went ahead and created a couple. There's no other reference. The only way to refer to them is their index 1 and 2 from that array. There's not really a good way to refer to them. Those are called anonymous objects. We will see a lot of that later this semester, anonymous objects. And then anonymous objects also can go a step further into factories, where instead of like that one thing we create from our blueprint, that really nice fancy thing that we're careful with, and we carry it around, cuddle it, and take really good care of it. Objects made from a constructor. Java also allows factories where we spit out a bunch of disposable objects. If we need to access a method, we can use a factory to spit out one of those objects, run that one method we need, and then delete it immediately. So kind of like factories in the real world, we spit out a bunch of disposable things, quickly use them, and then throw them away, or possibly take care of each one. That's coming later. For now, we can have the referenced objects or anonymous objects, and hopefully there's no surprise for that one. Turns out those strings, nothing too fancy there. But a little bit into the object stuff. I wanted to preview that because I have note to look at something in my to-do list, getting the course ready on my to-do list. I wanted to look at something before module 3. So your final project is actually due next week. Has anybody looked ahead and seen what it is? Seen the instructions for the final projects? Some head nods all around. So I guess you're all probably anxious for the interesting part. Right? Get past the syntax coverage and then get into interesting things. So we're doing more than we've done in previous classes. So we will be using Spring Framework. Frameworks are really nice. There are a lot of advantages for them. I could rattle off the list. You don't know how to use Google. Advantages of framework. Maybe throwing the word software if it doesn't give good results. But streamlining development processes, increasing database expertise. That's a strange way to phrase that, but proficiency, I would use that word. Better database proficiency than what we would do from scratch. Right, the libraries that people have been working on for years. We have to type less code. Debugging and maintenance is easier. Strengthening security, you can look through that, and as I scroll down here, you'll see there's lots and lots and lots of blogs about the advantages and disadvantages of it. The disadvantages are a little bit different. What was my idea? Disadvantages are a little bit different. You ever see any quiz questions that I wrote that refers to that? I typed up one today that I'm not going to use in this class, but if you encounter it somewhere, it's a general framework question. And I wrote, what is the which of the following is not an advantage of a framework? And it had several of those things. I actually copied and pasted one of the from a blog somewhere. For three of the options, and the fourth option was ease of use, which that is not an advantage of a framework. It's a bunch of pre-built things ready to go, right? Kind of like the analogous framework for our building in our physical world. Although we can go to Home Depot and buy every piece that we need to put together a house. There's no problem. Any of us can do it, right? It's right there on the shelf at Home Depot. We probably wouldn't even have to ask that many questions about which pieces we would need. But does that mean we're going to know how to build a house? A trip to Home Depot is not enough to know how to build a house. It'll buy the materials, and that's what frameworks are like. All of the pieces we need are there. They're built, they're ready to go. But there's a steep learning curve because we have to know the language they go with, then we have to know all the details about that library. So I wanted to preview this framework soon, the one we're going to use. Spring framework is it's really the Spring framework, and the new thing came out a few years back with starter files that make it so much easier. It's going to seem overwhelming, and I wanted to preview that early before I wanted to get it before week 3, so that you hopefully see that it's not that bad, because it's going to look overwhelming tonight in the preview. And try to follow along. I'll try to go slow, but this is preview mode. So if you fall behind, it's all being recorded. You can check that later. And the main one from this is to hopefully help you realize it's not that bad when you see that on the instructions for your final project next week. Spring Boot framework. The frameworks are awesome, right? Analogous to the real world frameworks for building a house. Right? We can go to Home Depot and buy every piece. We don't have to go in the forest and cut down a bunch of trees and split them into logs, or split the logs into boards, and then dig several feet down below the clay to find gypsum and make our own plaster. We don't have to do all of that stuff. It's all there ready to go. We just have to get used to how to put it together. But it's quite a bit, especially at first. So the first preview might be a lot here. Because one of the things you have to do is make a REST API, and that might sound like a lot. So we have to transmit data across the internet, part of our thing. And that's really, really easy. So I'm going to do that with Spring Boot in preview mode tonight. So let's open up a browser and navigate to the page start.spring.io. Start.spring.io. I'll copy that to the chat room. It's really easy. Whoops. Ignore that. I thought I hit copy, but I apparently did not. Copy and paste. There we go. That was still there was still something on the clipboard from answering a question in the Python class earlier today. Well, you can see from the label there, Spring Initializer. This gives us starting points. A whole bunch of starting files. So I keep mentioning Maven. So let's go with Maven in this class for your final projects, and that way we're consistent. Gradle is similar, and pretty sure anything we do in this class, both Maven and Gradle, would be fully automated in the background. We wouldn't have to go in. Oh wait, there's one line we'll need to go in and edit when we get to the very end of the semester. So there's one line we have to edit, and otherwise in between them, it's going to be fully automated. So we're going to do Maven with Java. The ones that say snapshot are in beta test. You don't want to be a beta tester. So choose a recent version that's not beta test. It goes to 3.1.3, which is a little bit back. Snapshots or beta tests, your beta tester M2 is, they're pretty sure that all the beta testing is done. It's been a minute since anybody reported a bug, but they want to, but they're not absolutely positive yet because frameworks are big, massive things, and it takes a minute to find every single bug. So look for one that does not have anything in parentheses afterwards. So it looks like 3.1.3 is the most recent one. And then we'll fill out the information on it. So group, who's making it. It needs to be something globally unique. So obviously com.example example is the generic one, and that's not really going to be that unique because that's very standard. If you have a website, the standard is to take the website and turn it around. So I use CS for instance 555. That's a reference to a really, really useful integrated circuit. One of the most versatile integrated circuits is 555. So I just use that electronics reference, and that's the website I pay for every year. So I know that's unique. So, but make up some words to put there. Then the name of it, demo. I'm going to change that to class demo. Let me do this. Oh, you didn't give me the error message. Artifact cannot be all uppercase letters like that. Maybe it will give the error message later. Class demo. I call it class demo. This one can be, the name can be whatever we want to call it. Maybe I will just keep it demo. Demo is a good name for it. Some sort of description. Yeah, because that is what we're doing, right? We're just doing the demonstration on Spring Boot, so we're ready for it. This will be important. In your final project, I mentioned this very briefly earlier tonight. You'll have to have JSP pages, and JSP pages only run from a WAR file. But for your starter files, the lake jar. That's the one line of code we have to change in the Grave, whether it's Maven or Gradle. We have to go into build files and add that WAR one later, because if we we've been using the Tomcat server, and I had to install XAMPP and do a whole bunch of complicated things. This will embed Tomcat server. So Tomcat is included in these files. So we want to use a jar file, otherwise it'll mess up the IDE, because we'll have a Tomcat server embedded in here trying to launch on a standalone Tomcat server. So that can cause problems. So that whole server thing gets a whole lot easier later in the semester. It'll be embedded in these files. And then when we do the final release, we package it as a WAR file after we're done with everything in the IDE. It confuses the IDE. So make sure you select jar, some recent version of Java. Notice Java 21 is not on there. I'll have Java 20 installed. And that is only the earliest version. So 17, where it's put for the default, is good because that's 17 and everything afterwards. So we can really go back to 8. That would be 8 and every version of Java afterwards, because this is what we assure backward compatibility to. We want to make sure we're backward compatible with 17. Or maybe you want to make sure you're backward compatible all the way to 8, which is still heavily used, because that's the last. Java 8 was the last time. Oh wait, no, Java 11. Java 11 that's on the list there was the last time there was a built-in GUI package in Java for desktop applications. Anymore, we use web applications, and then things like the electronic framework, which we will see this semester. Something I put a video out for it. Using the electronic framework to turn a web application into a desktop application does require 5 languages, and that's kind of hard to justify in a language-specific course. So in the final project submission spot, I did already put a video there for it, of how you turn your web application into a desktop application. It is very, very much boilerplate code. You'll copy and paste, follow along that video, copy and paste it, and you'll be able to use that forever with web applications. But it's several languages, so it's hard to justify. But we don't want to include some stuff. We don't want to start with just this starter file. We want to have other stuff here, right? So that's where the dependencies are. Instead of going and looking for them later, we did that the other day to kind of get ready for this. If we click on over on the right hand side on dependencies, Spring Boot dev tools are useful. You'll probably want those for your final project. We won't necessarily need them tonight. The big one we want is web. So Spring Web, just web, not necessarily reactive web. Webflux is awesome, but again, we're in a language specific course, so well, it's kind of hard to justify going into some of the other awesome stuff until we get to the end of the semester and we've covered all our learning objectives, and then we have just time to fill in odds and ends. Then we can look at some of the other awesome stuff that isn't part of that. But Spring Web, you just start searching for web, and there's lots of things in here. So if you want data, JPA does SQL stores, or we could do Elasticsearch, Reactive Relational Database, JDBC. That's the one we're going to study in class. JDBC, Redis, that's an in-memory one. MongoDB, it's already built into Java. This is the starter files for working with it. So things like that can be really, really useful for now. And for your project, the main one you're going to want is web. Notice it says RESTful. So when we transmit data across the internet using the RESTful protocols, that's which we will talk about more in detail later. We're in preview mode right now. That's what a REST API is. API means application programming interface. That's the tools needed to program with. So Java is an API. This website now is an API. Usually when you hear somebody say API, they're talking about a RESTful API, which we abbreviate and say REST API. Because having an acronym wasn't enough. We had to cut off we say half the acronym just because it's easier to say. But a REST API is when we transmit data across the internet using the RESTful protocol. So RESTful, I guess we should probably look into what RESTful is. Oh, I guess I'm doing input API. So that's the definition of a protocol. So that's not very helpful. Definition of protocol for integration application software is some. Remember how I said that earlier tonight? I took a moment to pause and talk about coding by contract. That's what RESTful is. Yeah, contract. Y'all can look up stuff and see what the acronym stands for, but I just did a quick search, and at least the first 5 pages, 5 results here, I can tell that they're just summarizing what a protocol is. They say RESTful and then give the definition of a protocol. But a really easy thing to find, but in summary, it's that thing I previewed earlier tonight, that code by contract. Both computers already agreed on what's going to happen, what's public, what needs to be given, what gets back, what you get back for giving a certain thing. That's RESTful. So we need at least the web. There's more that we will see, lots and lots of them in there. But if we add the web API, the web one, yeah, Apache Tomcat is the default embedded container. So if it's embedded into our program, we don't need to use that when we install. So make sure you download the jar file, because that Jamf one uses a war file. It builds the war file and then launches that on there. I should probably show it somewhere soon. And when done, just hit the generate button. So choose Maven and Java. The latest version does all parentheses beside it. Snapshot your full out beta tester. Y'all do not want to be beta testers in the classroom, right? You're learning Java. You probably don't want to try to debug Java while you're learning Java. So use the latest one that does not have any parentheses beside it. And generate those files. Then it should be in your download folder. And it should have downloaded a zip folder, demo.zip. You can do it from, you can unzip it and use the open project button here. I usually go to import because the import has an import from zip. So if you go to file and import project and import from a zip folder, then we just need to navigate to that zip folder, which is on this PC, might be bigger here, which is under downloads. Navigate to your downloads folder and just choose that zip folder, and we can import it. It's gonna come in and say there's, I can't do anything, unloadable. And the problem is we haven't built it yet. We do have to build it once. Oh, that's the problem. We go to other sources. Well, there doesn't seem to be any static things. I hope this isn't a problem. There's something you might have to do later. I'm just gonna go check and make sure that's why my computer's not doing it. When did I do stuff here? You might need to come to your profile stuff. I'll show you where this is at on Mac users later. If this is the very first time you've done anything with Spring, you want to do it. And I'm just going to delete this repository here. And now it should be ready to build. So if I right click and clean and build, we downloaded a bunch of things that have never run at this computer before. That thing I just went and deleted, that repository I just went and deleted, is because I've run other things that were slightly different, and it got a little confused about what's what. And so now it's a Maven project, so we went and checked the whole Maven repository and everything. Downloaded, made sure we downloaded all the stuff. Yeah, right now, if I come back over to that thing that I just went and deleted, so under my user profile, which is in a slightly different place on a Mac, but should still be just as obvious. I'll show you where it is on a Mac before long. I'm trying to have to need that. Notice the repository folder came back. So that's a generated folder, and there was the wrong things in the generated folder, so it confused NetBeans. I didn't think we were gonna have to see that till later. We close this, and now there's a bunch of things here. So we have a source packages, and notice the name com.francis. That name I put in there. .demo, but the package name is really, really long. That relates to hashing. So when we get to hash keys later, I know you all are familiar with the word hashtag, right? That comes from Java programming language. That's the second thing. That's the second big one that's normal English. Right? If y'all remember week 1, I mentioned the streaming. Y'all know that word. That comes from Java. Hashtag hash actually comes from C++, but you know it from Twitter, and that was the one that that it entered the program common English from Twitter, and that one was done in Java. So Java has a really big place in our world. It's not a small language to know. So here's our main method. If I go in that package, the reason Maven does that is it creates better hash keys, which you probably know as hashtags. But we should probably use the proper term, hash keys, for a hash table. We'll talk about what that is. We will definitely see what that is. We'll spend quite a bit of time when we get to data structures about that. So here's our main application, right? That public static void main string args that's built there, and notice that it just has this thing here that says demo application, and just it just calls this run method. So we don't actually, that one's ready to go. We don't have to worry about that one. Actually, I can go ahead and hit run on this. So whenever it comes in, if you get a message box about some needs to fix something, just go ahead and click the automatic fix on it. It might still show some more stuff, but before then do a clean and build. What? Hold that going. Go to compile. Oh, could not find or load main class. So this is the thing we saw earlier. It doesn't know where the main class is. So I come over to the project and right click on it. And under properties, which should be all the way at the bottom. Yeah. Under properties and run, we just need to tell it what the main class is. So start. There's only one option. It already looked through every file. It already looked through every file. And then we said, oh, only one class has the main method. It has to be this one. But it won't actually pick that one for us. Zoom buttons are in the way. There we go. Hit OK. So now if I hit run, so with the starter files from Spring Boot, you do have to right click and clean and build the project and then explicitly tell it where the main method is. And why did that not run? Identify and stop the process that's listening on port 8080. Port 8080 is already in use. I have no idea what port 8080 is in use. Is Jamp running? Yep. Apparently Jamp is running on my computer. So this is Tomcat, by the way. We have the management page. If we go in here, not authorized to access that. So is that running through NetBeans? I have to go find where Tomcat's running from. Let me see if it's running from Jamp. Yep. So it's running here. So I'll go in here and stop that running from port 8080. There's a good chance it's doing that on your computer too, right? So just go in Jamp and stop what's running on that port, or sometimes it might take a minute to track that stuff down. And my computer is really, really fast to restart. I kind of keep it that way. I do go in and configure things so it's really, really fast to restart. So personally, what I'll do if I see that message a lot of times is I'll just restart the computer and like go refill a cup of coffee and then come back. And obviously a restart's going to shut down all of the processes that might be doing it. And over the years, I have found that can be a lot easier than digging through trying to figure out what's using that port. All right, so now if we run, yes. So remember I said if you see a question about advantage or what's advantages and disadvantages of frameworks, ease of use is not an advantage. Takes a minute to learn how to use them. A lot of things there, kind of have to know what's going on with them. Oops, I did not mean to hit run twice. And notice that it came down here. We see Spring, the message, we're in the Spring framework. Then it starts booting things up. Second one from the bottom, we see an embedded Tomcat is the second from last thing that was running. So it started up a Tomcat server. So if we go over to localhost port 8080, we see an error message. We use a second to read that. But that's clearly not from the browser, right? That's clearly a very explicit. This application has no explicit mapping for errors. That other one I quickly pointed out on the starter file, the Spring Dev Tools. Actually, I guess I could have added that. That will show your error messages in the browser. It's very, really useful when we're debugging, but we'll see that when not in preview mode. We're in preview mode tonight.
Question again. I'm sorry.
It's fine.
I drank that Polar Pop and
It's so there's no error message, but we don't have any output either. So there's nothing at this point. This is just the default state. We didn't send anything back. So we need to add some stuff. We need to make a thing that will return some values. So we're gonna right click on that package and just create a new Java class in it. And there's lots of new buttons. There's one here, there's one up here in file, but it's really easy. You can see how many folders we have here, right? There's folders all over the place. They're not even all showing. Under this one, under other sources, oh, there they are. We have static and we have templates and we have a whole bunch of folders already in our project. So it's really easy to put things in the wrong spot. So I want to make sure I'm in the same package as the main class. So that's why I like to do the right click. And that does work in most of our IDEs because it's a common problem. Create a new Java class, it's on the short list, or we can go down to other and search for it. Under other, and under Java, create a new Java class. What will this be? This is going to be our data controller. That's not a good name for it. Because we're going to make a really quick REST API tonight. We're going to see what a REST API is, which is really, really easy in Spring Boot. That's why I wanted to preview it. And I'm going to call this data controller and get rid of all of this stuff. And what do I need? REST controller. I do Control-Shift-I. So I added this annotation at REST controller. So this is the class that manages our RESTful API to send data back. So we do need a data class. We haven't actually got to object-oriented stuff, but I wanted to preview this before week 3. So we did a quick preview of object-oriented stuff, and you all have seen object-oriented stuff before, right? So let's go make a Java class. So I'm going to click on the package again, create a new Java class. What's a good one? I'm new people. Those who have had me in class before, you've seen my common example, right? Classroom example, my standard one, if you haven't had me in class before, is people data, person, and just do name, age, and town. That's a good quick example. So I want to make person type of data. Finish that, get all of this stuff out of the way, and then we saw earlier tonight, we can go into template and change that. So person, and this is just going to be a data class. This doesn't need a bunch of super fancy stuff like we would put in, say, an object for a video game. A video game object's can have a whole lot of complicated stuff in there. It's got linear interpolation, which when we code is probably just the pre-built function ler. Usually shows up in 600 level math classes. If we actually have to do the math ourselves, type in the math ourselves, it's a complicated thing. We don't need that. We just need something to hold our data, right? Really, this would be an intermediary between the database and the user. So we need to pull stuff from the database, put it in an object that will work with our software. So we just need some data fields. And we want to make it a bean. So Java beans, let me write this on the board real quick. These are important. Really what this is a method or a convention for making objects. Objects or classes. So All data fields are private. Include the default constructor. The default constructor takes in it doesn't take in any parameters. Just has a method with blank parentheses, so no parameters, and it doesn't do anything. Getters and setters for all data fields. And we want to override the string method. The two string. Minimum of these four things. Actually, I'm gonna go ahead and add one more in here. Oh, I'll just say the other one. It also implements the serializable interface, but we won't see that, and that's so that our toString method can write files. But we'll skip that one for tonight. It's a method, a convention of doing things. That point I mentioned earlier. If we all write our code in the same way, we end up with a lot of powerful things happening that we don't have that don't happen in other programming languages where everybody does their own thing. One we'll see this semester is with observables, and we can parse somebody else's code. We don't have to parse the output of the code, we can parse their code. So one of the big conventions is what we call Java beans. Also, there's a lot of things that are coming from that. We'll come back to this over and over again. But all our data fields are private. We include a default constructor, getters and setters for all the data fields, and we want to override the toString method. Sounds like a lot, right? But it's once we set up the data fields we need, it doesn't require any more thought to do the rest of that. So it's code we can generate. And it's code we want to do every time. So we're in person. So my standard example in classroom is people have a name, age, and town that they live in. Sometimes favorite food if we need to add more stuff. But let's just do name, age, and town. So to follow the Java, make it a Java bean, the data fields need to be private. The name is a string, so I have a string called name. Then we'll have a private data field. Ages are technically floating point numbers, but we give those in integers, right? Once somebody passes 2, we don't give a fraction of a year anymore. I guess, well, maybe when kids are telling people their age is up to about 4.5, they'll say that because they heard their parents say it. But usually by about age 5 or something, even little kids notice that people don't give fraction ages, and we just go back to integers after that. So private int age. Count's also going to be a string, so let's say private string count. And this is what we need for an object. Objects are made up of primitive data and already existing and pre-existing objects to store our data, and then methods to handle them. Well, we just need a bean. This is a data class. It's an intermediary between our database and the end user that's accessing it through a browser when we transmit the REST API across the internet. So our data fields are private. We need a default constructor, the getters and setters, and the toString method. So in NetBean, if we push Alt insert keys, the insert button's at a different spot on everybody's keyboard. Does everybody know where the insert button is on your keyboard? So Alt insert, and we need a constructor. The default constructor is the one that does not take in any parameters. So uncheck all the boxes and hit generate. It doesn't take any parameters, and it doesn't do anything. So empty parentheses, then empty curly braces. We have to have that constructor, and we can have more. That's like the minimum. We have to include this. If we make 10 more constructors, it could still be a Java bean, as long as it has at least those things. And the serializable interface, but we won't see that till the week after next. Now we need our getters and setters. So again, Alt Insert, getters and setters for everything. So hit the select all button and generate that. And then we want to override the toString method. Alt Insert. Well, toString is explicitly there, but we also have this one for override method. I'm going to override. All Java classes have these things. This is what we inherit from object. We have clone, so a way to make a copy of ourselves. Equals, so we have a way to check equality. Finalize is deprecated, but it still works in some situations, but it's deprecated, so probably don't use it. Anytime you see something crossed out in your good IDEs, that means it's been deprecated. It does still work. I often use the date method that was deprecated in Java, in the second version of Java, so like 1992. Been deprecated since 1992, and I still use it, and it still works. It just has a line to it in the IDEs. But we should probably avoid those in the class, just because that's bad form. So we don't want to practice bad form in the classroom. Hash code, that word's already shown up a few times. We'll go over what it means, and toString. So we want to override the toString method. Let's check that. Those are all things that we have. So whenever we say print, that system.out.print line, it calls this. Anytime, if we try to concatenate, we have a new string and then like empty quote marks plus anything else, an integer plus a floating point number plus a Boolean plus this object we just created here. Anytime we try to concatenate that to a string or do anything with it as a string, this automatically gets called. That's why we have it everywhere. We probably don't want the default one. Here's string building. Let me see. Notice that, and it added an annotation here at override. I like to refer to that as the most misused word in Hollywood. Y'all ever seen like the movies where it's like coming down to the wire and hero of the movie they can try overriding something. Override means change the default value. Next time you see a character in a movie say they're going to do that and then save the day by overriding something, imagine that character saying, I'll try changing the default value. And it really seems quite ridiculous, but I guess it sounds fancy. Either that or Hollywood writers still don't know what it means. But we're going to change the default value of what the toString method is. A people object. So anytime we try to print this one, for example, it's going to say a people object. I think I blended two words together and actually it ended up as a different one. A people object. We're not going to actually use that in our API. We're going to use the getters and setters. But notice how quickly we wrote 45 lines of code. It's pretty much all generated there. So we do a lot of that in Java. So there's a whole lot of generated code. And you saw that list of the code generation was a lot longer than those couple things we clicked on. There's a lot of that because it doesn't, setting up our variables is the only thing that required any thought there. So I'll save that. So now we have some data. So I want to make a method that returns this. Try to look at an example. I don't mess anything up. Probably look at an example. I didn't get on another computer, but I have stuff I can get up. I think I put it in one for our class. Might not. Fall 2023. Nope, I did not put it in the repository for our class. Oops. right here, and this is the one I use for videos. So when you see videos, this is one of the ones you'll see there in the videos. Okay, is this not it? Yeah, that's it. Oh, that's the test. The main. Then we have to check the main. The iOS controller. And well, looking at my example here, because it's been a minute. So this is basically what we're going to do. We make a method that returns a list of the object we're using. I decided to show this because that way you see it in two contexts here in preview one. This one has restaurants, but and your final one's going to have something else different. But we want to return a list. We talked about those the other day. Return some type of list, and it's strictly typed, so we have to say what that list is holding. In our case, the list is holding that data class we just created. And we are in preview mode tonight. I know everybody's seen object-oriented stuff before. That's why I didn't mind rushing through that. I'm jumping ahead a little. There are two prerequisites for this course, so I know you've seen it before. Next week, we are going to dig into that stuff in detail that we just rushed through a moment ago about what a class is. So I listed the other day, so we need our method, code by contract, that our RESTful API, RESTful protocol, promises that it will return a list of person type objects. Then a name of method. That's probably not a very good name. Show all people. That's a good name for it. And we don't need any parameters in this case, but we do need to set up a list. Array list and linked list. So list is abstract. Actually, list is an interface, but it's abstract. We can't make just a list. We need something concrete. We'll talk about concrete and abstract 2 weeks from now. But list is like a category, not an actual thing we can use. So we need something from that category. So array lists are pretty common. Array list, a person, people is a new array list. And it's obvious what the type is, so we don't need to put the type on both sides. As long as it's obvious what the type is, we don't have to duplicate it. Then I'll hit Control-Shift-I to auto import stuff. I want java.util.list. Those look like the ones I want. There's some ambiguity now. We use that Spring Starter framework, so there might be some other things called list. But I want just the basic one from Java util. So spit up a list. Now we can add some stuff to the list. People.add, and we could make a reference, right? Store this in a variable and use it somewhere else, but like we saw right after the break, we also have the option of anonymous objects. We don't need a reference to things if they're all going into an array list where we can just index them. Because we have like index 3, index 17. We have those indexes so we can refer to them that way. We don't need a second one. So we can just do a new person object right here. Has no parameters. Because by the nature of a bean, we have to have that default constructor. Right now, it would be pretty useful to have a constructor that we could pass in the name, age, and town. And that way we don't have to use all those setters, right? So we can have more than one constructor. I'm going to come over here and row below that and hit Alt Insert again and generate another constructor that has all of those things in it. The bean conventions just mean we have to have at least the default constructor. That's at least. We can do more. let's add a constructor that has lots of options, then we can add in a name. So like say, Sally, who's 22 from Salem. One. We also have a dollar method. I'm gonna do them one line at a time. People got to add. Instead of adding, do add all and list out a whole bunch of things, I'm just gonna do add a bunch of times. Which actually is a copy and paste thing, right? So probably just put cursor at the end and hold. If you haven't seen it before, prior to to using mouse, we would hold shift and like the arrow keys to do highlighting. Since it's pretty common that we want to highlight a whole line in code, what I like to do is put the cursor anywhere on the line, then push in, and if you hold shift and push home, it'll highlight to the beginning of that line. And I always do in first because if you hit home again, it toggles back and forth between the indenting. So I start at the end and then come back and then do home second. But it's a really quick way to copy and paste from the keyboard. And then I'll hit the N key and then enter and paste that a bunch of times. There we go. So now we just need to change these things. And this is something I pointed out the other day. It's a little counterintuitive just because of the language our spoken language in English, Spanish, German, Romanian. There are lots of languages around the world, right? So, but in English, we work left to right, top to bottom. We're in Java, so left to right, top to bottom isn't necessary. This sort of thing happens a lot, and working down the columns can be better than others. Like if I put the next one here, Chuck, oh, whoops, Charlie, notice how the columns don't line up anymore. So what can be better than that? It's even better to work right to left going down the columns. Because if I come down here and do a bunch of like town names, Charlestown, New Albany, and Marysville, and Corbin. Gabrielle probably doesn't know any of the names of these towns. These are all small towns in our area. Sellersburg, the one campus is on. Notice how now the age one still lines up. So we're going down the column. We don't have to constantly change our frame of mind back and forth. We just think about like in that case, towns, and they do all the towns. And then we only change our mindset once to go to the ages. So change that to a 37, and that one to a 82, and this one to a 14. Just go down here thinking about the ages. 25 and 65. And the names are still lined up where we can go. Now we change our mindset once and think about all the names. Names, ages, and towns probably wouldn't follow that pattern in a real situation. It works here. It's just making up these. I'm just making up these. These do not represent real people. But we can kind of go down here. So Charleston, we have a double click on that, and we have a Charlie that lives in Charlestown, and Alan that lives in New Albany, and Mary that lives in Marysville, Corey in Portland, and Shelley in Sellersburg. That's close enough. But working down columns like that, that's something that happens a lot, and it can be a lot more productive to go down the column than across. That gets us our list. Only thing that's missing is our promise that we were going to return the list. We have one, so we just need to return that. So return people. So that builds the promise. Now what we need is a way to access it. And just like we put up here right above the class, we use this annotation. That's what we call those, if you haven't seen that before, add rest controller when that does stuff in the code. We'll see how, we might add some stuff to it. I don't know if we'll have time to get that in this 8 weeks. When it was a 16-week class, I think I added it 3 of the 4 months of the course. But it's in an 8-week course. I don't know if we'll have time to add the annotations, but it's really, really easy to do so. Once we get to the end of the semester, and you've seen a lot about Java. It's like if we don't have time for it, I have a YouTube video in mind that I'll send you because the guy is great. He has lots and lots of short videos. Like the longest video he's ever made is maybe 20 minutes, and he's really, really good, really, really thorough. But they are not introduction to Java videos. They are definitely video tutorials made for people who already know quite a bit about Java. He just dives into the details about the stuff. So I'll give you that list at the end of the semester if we don't have that video at the end of the semester if we don't get to it in class. So we can use, and we use annotations for a lot of things. Spring Framework is built, there's tons of stuff built around around annotations. So notice at in our main class, what the main method is that was generated for us, there's an annotation that says at Spring Boot application. Probably should have put one there, but I'm gonna skip it for now because we're just in preview mode. And on our data controller, we say REST controller, and we'll do the same thing here. This example pulled up. Add request mapping. This is the one we do for everything. We want to request a URL mapping for this, and then we enter a URL. I just wanted to point to that example. So add request mapping, and we need one or many URLs. I'll do a list. So can you see that on the screen? Can I zoom in? Oh. Yeah, Control plus doesn't zoom in here. So inside of parentheses, we put our mapping. So maybe we have a /home. We'll call this the home page. But if it's a home page, we might not necessarily have to type it. So I'm going to add curly braces, so it's like an array, and do an empty string, comma, and then the word home. It's kind of small there. We can do one or many things. If it's one, just put it right in the parentheses. If you have a bunch of URLs that you want to go to the same thing, you'll put them in curly braces. We will see more of this later, but preview mode so that you're so it's not overwhelming by the time you have to start doing it. I think the REST API homework assignment is due in module 5. Ease of use is not a strong point on, or no, they are easy to use. The learning, there's a steep learning curve for this. Okay, just getting started here is a whole lot more than we saw just getting started in Java. So there's a steep learning curve, but there's a lot more that can be done very quickly and a whole lot of things happening in the background. These annotations do run, that is stuff that happens in the background. We need to import that, so we need Control-Shift-I, or you could type in that word right there. You type in all of that if you want. So Control-Shift-I is a lot easier than typing that in and hoping we don't make a typo typing in all of that stuff. Seems like a lot, right? We actually have a REST API going now. So this is where we get to the advantage of a Spring Boot framework. Y'all have never seen Spring framework, Spring stuff before. What was it, before 25 minutes ago? You've never seen it, and our REST API is ready to go. Unless I made a typo while talking, I should do a typo check before I say that. Now we see the advantage, we should see the advantage of framework if it doesn't crash. Didn't crash. So, it did. Something's running on the board. Oh, that last run is still going. That's how I closed the output window. But when I hit run, now there's two things that say run demo. So the previous run is still going. So make sure, this is something important. Yeah, cancel the one. Always make sure you hit that stop button here because we're using an embedded server. So we get that error message we just saw. When we go to run it again, the previous run was still running. So now all of the runs are done, and if one's running, it shows down in the status bar, so you can look at the bottom of NetBeans and see if it's there. Let's try that again. We hit run. Does all this. All right, launch into the server. Give it a second. Okay. This time the server didn't try to access that port to find out the port was busy. And notice down in the status bar it says that something's running. So you can watch it down there. Just make sure you hit the stop button when you're done with it, or before you run it again. The big red button, the big red square is stop. Now if we go to localhost, port 8080, and notice that one of the URLs I put in is blank string. So localhost port 8080 is like the domain, that's the server we're on. But then we don't add anything else, nothing else added to our URL, the blank string, and it should return this API. So localhost port 8080, I want to get an error message. Okay, oh, I don't know. I should have done that. Let's see what I did. I put in the blank string, but I should have put in a slash. Instead of just leaving it to imply that there's a slash nothing else would be just a blank string. But when I type slash home, yours probably looks different. I have a plugin to format JSON nicely in Chrome. If you want to install it, it's JSON formatter. Since we will be working with REST APIs in this class, maybe some other class. JSON formatter for Chrome. There's a Chrome extension you can get from the Google store for formatting that. And if you use other browsers, obviously Mozilla Firefox and every other browser in existence, Safari might not. But almost all of our other browsers have some sort of formatter plugin you can use. Just search for the appropriate one. Search for the one on your appropriate for your computer, because it's kind of hard to read in the raw form, right? This is what we would want to use it in code. So that's the actual form that we go into another program we would use in software on the other side. But when we're debugging stuff, we want to be able to read it. So there's our REST API. Never seen it before and took 25 minutes. There was a lot of stuff there, right? It did take 25 minutes, but the REST API is a pretty big deal. We have a data set securely transmitted across the internet. We will see how to add parameters and things. Let me come back over here. Stop that run. And when I did the blank string, that threw an error message. So if I put a slash in there, so now instead of a blank string, it's slash and then nothing else. Hopefully that makes sense as to how that is more appropriate for URL, right? Domain name slash nothing else. Oh, I didn't hit run, did I? I stopped the previous run, so now I run that. And it should just take a second. Reload it. There we go. So if you want a blank URL, use the slash to the top level. Tons and tons of stuff that we can do here. We should have put it in telemetry to our confidence. We could have looked at some cool features here. But that's what the REST API part of your project will be. You'll want to, it'll be further from that. We're in preview mode tonight, so we might want some stuff where we could add, um, some sort of queries, right? Adding query strings and look for a parameter on, a asterisk. Any names that start with A. Has everybody seen a little bit of SQL before? So we could add in query strings. We need to add parameters in order to do that and filter through our data set. But right now, that's what it takes to get securely transmit a data set across the internet. Which won't be part of your project. We'll see that in a couple weeks, but does that seem fairly easy? Well, I don't know. That's overwhelming right now. I understand. I remember the first time I saw frameworks. The steep learning curve is definitely the main disadvantage of it. Once we get in there, so much stuff is done on the background. The other day we looked at, if we come down here and expand the project files, we're in Maven, so here's our build file. Look how big this build file is. It's already 42 things. Came with these dependencies already. We can add more to it. All of that's in there. And default packages or anything in application properties. Nothing in application properties. We will add a bunch of configuration stuff in here. Maybe port ports. Ports. Maybe I don't want to go from port 80. I want to go to 443. No, I don't want to do 443. Instead of 8080, I want to go to port 80. I think it's ports. It might be port. Stop the previous run. Yes. Stop the previous run. Make sure there's nothing down in the status bar and then run that again. I rarely change TalkNet for one of these other ports. For anybody who's had like the SDEV 111 course, it's probably not even SDEV 111. If you've had a course where you've encountered proxy servers and load balancers, that's a way better way to do it than just giving access to your stuff. Oops, let me keep that in port 8080. Oh. Yeah. Port number in Spring Boot. Server.port. I almost never do this because it's actually kind of insecure to do this, but it's a nice quick example. So I guess it's okay so we could say server.port and instead of 8080 run on port 80. Be a little bit better to do on port 443, but I'm not sure if Chrome would get mad because I don't have any digital certificates on my local machine if I tried to use HTTPS. So I'll go back to just port 80, which port 80 is your default HTTP port. So that means we don't have to type a port number if we're on 80. If we're on 80 and 443, that's HTTPS. We don't have to do that colon port number. So just right there, it's really easy to configure that. And notice that now I don't have to put port 8080 and do it this way. Really easy to do, but that particular example is kind of a security risk because we just gave basically unrestricted access to our data API. Not just people that know the port number, anybody can access that API now. So that one, a bit insecure, but I'll leave it here for configuration stuff. Sometimes you might want to do that because like AWS, Google Cloud, Oracle Cloud, all of the cloud providers charge extra for load balancers because of that right there. Putting our port directly on port 80 is a security risk. So people want to use load balancers and proxy servers, but that's a security risk. So Google and Amazon and Oracle and everybody that provides cloud servers charge extra for load balancers just because of that right there. Because people have to get around the secure thing, so that might be a good reason to do it. To save on a bill if if it's a situation where you're not too concerned with it. And then all of our configuration looks like that. We just have like one word and a value we assign to it. I used a colon, equals also works there. But things are made easier because we don't have to set up a proxy server and a load balancer. Spring automatically set up a proxy server and a load balancer for us. Some of y'all in this class of mine have no idea what I'm talking about when I say that. And it's automated in the background here with the framework. So things like that are a lot easier, but there's a big learning curve. So hopefully that at least doesn't seem overwhelming now. Does it seem like something quite doable? In particular, just think about this. Look at all these files that were generated for us. So this is cutting out all of that work, which in some ways makes it more like coding in Python. Because that stuff has to be done. All the stuff you've done, there's a lot of stuff in Python that runs in the background that we have no access to. The main difference, this makes it like that, except that we can access that stuff. We can still go in and control it and change it if we want to, but there's a default version, so it's like Python, we only have to type the couple lines of code we want, right? Actually, those were the only lines of code we really typed. This one was there for us. This one, we typed those 3 lines of code and everything else in this file was generated. So it's not even a lot to type. That's what I wanted to look at tonight. Preview that and see that it's not a lot. And then that thing under other sources and template files under default packages, the configurations, the stuff like that is a bunch of keywords, and we just do assignments. Really short things like that to set up all our configurations. We'll see more of it. Hopefully that was enough that you feel like it's not going to be completely overwhelming. And that's what a REST API is. We transmit the data almost always in JSON. This is definitely going to show up in our class. JSON is by far the most popular, but there's a reason for it. XML markup languages are better for strictly typed languages. JSON, which is JavaScript, is better for dynamically typed languages. JavaScript is the standard for websites. So it is overwhelmingly the most popular programming language in the world. So much so that we don't even count it. We just go ahead and skip to number 2 and say Python is the most popular programming language in the world, because nothing can compete with an official worldwide standard, right? Obviously, the official worldwide standard for something is number 1 by an overwhelming majority. But JavaScript and Python are going to be the most popular languages used, most common languages used in the world. So odds are we're going to be processing stuff on a dynamically typed language, not a strictly typed language. Markup languages are better for strictly typed languages. It does saves as nanoseconds, which seems very, very small, right? But think about data sets in the modern world. How big is Amazon's data set? I'll keep using the example of Humana here in Louisville. 50,000 employees, millions of customers. How big is the data set they transmit? Deal with it. So what is a nanosecond per data point? That's going to add up to like go get lunch and come back and it's still doing stuff. Just saving nanoseconds. So it does add up. UPS's data set. That's a massive one. Another one centered here in Louisville. How big is UPS's database of all the packages moving around the world right now? If we save 3 nanoseconds on every single data point in that database, that's going to be a lot of time, right? Like human noticeable time, like go take a lunch break sort of time. So it does add up. computers have gotten fast and powerful, but we can still bog them down. Any gamers know that. We can still grind a computer to a halt. I was doing something in Blender over the break. We were actually drawing pictures, and I made some photorealistic waves. They look great. Rolling up on a rocky shoreline and grass waving in the wind, completely procedural, it's completely done to code. It brought my computer down to 4 frames a second by the time I had everything going with full photorealism, and it was on 1 by 1 meters of each. That's how much the quality I put in there. Now, it completely used my GPU and then overflowed back into the CPU and brought it down to like 4 frames per second. So the waves weren't really crashing on the shore at speed. Oh, it was 3 by 3 on 3 by 3 meters of 3 by 3 meters of grass, 3 by 3 meters of rocky shoreline, and 3 by 3 meters of waves crashing on them. So it is definitely quite possible to bring them to a halt, even if, I went with this. There's still plenty of stuff we can do that will overwhelm them. There's still plenty of stuff that computers can't even handle. That boundary between computable and non-computable, that still exists, but that's a different point. When we can be more efficient, it's a good idea too. And there's a lot of that in this semester. This is a software development class. Usually software developers just worry about making it work. Computer scientists worry about making it work efficiently, optimizing it, but that doesn't mean we can just disregard it, because we can still bring computers to a halt with little milliseconds and nanoseconds at a time. So now we need to put this on the repository. So I'm going to go over here and grab the version of our repository, and I'll jump into PowerShell. Grab the link. So Windows X and I. So navigate over to my working directory. Everything's empty. There we go. So I have the URL for the repository. So I'm just going to git clone and then paste that in, and that will make a copy of the repository here locally. Same name and everything. So now I can jump over to File Explorer, go to the NetBeans project. So here's the examples from Tuesday to 9th. Yeah, here's all 3 examples. So I'm just going to copy those, put them into the clone of the repository here. Those are some awful names, so I should change those names. This was I got click one slowly, demo of Spring Boot. That way, if y'all want to look at this stuff, it's has some useful names. Java application 3. This was I'll name this in class method examples. Example. What did we do the other day? That we did arrays. Lecture array example. And then this one was list. Lecture list example. So I just copied and pasted them over to a copy of the repository. And now I can go over here. In our terminal, we want to stage the files. So actually, I need to navigate into that one. So I'll navigate into that one. Git add dot. It says we're not in a repository. So CD to navigate over to SDEV 200-fall 2023. Now we are in a repository, so say git add, then dot for the current directory and all the subdirectories. It gives a message I made on a Windows machine. So I have my text editor set to do just line feeds. So Git is going to change that to carriage return line feeds. Doesn't always make a difference, but sometimes it does. carriage returns like a typewriter, that wheel would spin, that's a line feed. But on typewriter, when it would spin, you would still be like all the way over at the side of the paper. You wouldn't be at the beginning of the paper. So the carriage return is when we brought it back to the beginning. It usually doesn't matter. In most situations on computers, there's nothing on the next line. It's not a blank piece of paper like we had at a typewriter. So the only place we can go is to the beginning, but not always. So a carriage return just assures that we go back to the beginning. It's going to put all of those in there. So now the files are staged. We want to commit the changes. So git commit. And if you just type git commit, it'll open up a text editor, probably VI if you don't know how to use VI. If you don't know how to use VI, you probably don't want to. It's going to confuse you. So add -m and then some sort of message to keep this straight. Module 2 examples. That sounds like a good message to tell which commit this was. There's all the files that's changing. So things have been committed, so I can do git push back to the remote origin on the main branch. No error message, but over here in GitHub, we should see the files are there. Yeah. So all the files are up there now. GitHub is named after Git as far as what happens in the terminal. Those terminal commands are around long before the website. It's just one of many file stories we can keep code at. So those examples are there if you want to refer to them. There's also the video. All of those examples were recorded along the way. What does that leave us? 8:54. So that leaves us about 56 minutes of class time left. It is a lecture lab time, so it's a great time to work on stuff. Until 9:50, I'm just going to be sitting around waiting for questions. Text messages and iLearn messages are the only two things that make noise on my phone. Until 9:50, I'm just going to be sitting here waiting for questions unless everybody leaves, in which case I will take the 10 minutes to back to Clarksville, so there will be a very short gap, and then I will continue just sitting around waiting on questions until 9:50. So it's a good time to work on stuff, but these long classes are exhausting, right? Mental exhaustion is extra exhausting because physical exhaustion, our mind can tell our bodies to just push on through it. But when we're mentally exhausted, our body's never going to tell our mind to push through it. Our body's like, okay, yeah, rest, sleep sounds good. Doesn't work both ways. But rest is productive. Taking a break and relaxing for a few minutes, don't overdo it. But resting, if you rest when you're exhausted, you will be more productive than if you would have tried to push through the exhaustion. So resting is a type of productive. Please use your time productively. If you have any questions, let me know. I do teach more than just this class and can help with more questions than just Java questions. So if you have any questions, send them my way. Obviously, for the next hour, Java questions should probably take priority because that's on our calendars. Otherwise, you all have a great weekend. Remember, college campus is closed Monday. So nothing happening Monday. Career Link, somebody from the Career Link, from maybe one of the career coaches is going to come in. I think the career coach has to be at the soccer game is what I heard. So maybe not Sandy, but somebody from that department is going to come in and talk about that. And that's why everybody's at school, right? To get the good job. So we definitely want to give that department our undivided attention. Then we'll get into object-oriented stuff, and we'll spend about the next week and a half on that. Otherwise, have a great break. I heard it's supposed to be really nice weather for the 3-day weekend. I'll see you on Tuesday. Let me know if you have any questions. I stop the screen share so I can get to the stop recording button, and I'll see you next week.